Good afternoon, Professor. I am going to present my presentation topic of tidal power. The tidal power. In our group, we are three guys: Sanam, Singh, Singh, and Abdul Hai Alvi. The environmental sustainability presentation, our instruction name is Joshua King. So, if I talk about tidal power introduction, tidal power is a renewable energy source that generates electricity by harnessing the natural rise and fall of ocean tides caused by the gravitational pull of the moon and the sun. Like it's all about the moon and the sun gravitational pull. It is reliable and sustainable energy solution using tidal barrages, underwater turbines, or other technologies to convert tidal movement into electricity. Like it is the form of hydropower. So it was the introduction of the tidal power. If we talk about what we are going to cover in this presentation, and the PPT file has covered, the points are that understanding tides, how tidal power works, types of tidal energy systems, tidal barrage systems, tidal stream generators, dynamic tidal power, that is called DTP, advantages of tidal power, challenges and limitations, leading tidal power projects worldwide, future of tidal power, comparison with other renewable, and in the last, we will provide some reference links from where the content we have picked up and all the stuff there will be given. So first of all, we will talk about understanding what are tides. So like there are two types, high and low tides. The rise high tide and fall low tide of sea level due to gravitational force. Like if I explain, so this will be like which is the high tide, that will be the rise of the ocean, and which is low tide, that will be the fall of the sea levels due to the gravitational forces. And if we will talk about moon, sun, and earth's rotation, so it will be like the moon's gravitational pulls ocean water, the sun enhances or reduces tides, and earth's rotation moves tides globally. So the mainly here topic it is about the moon gravitational force, the sun enhances and it reduces tides, and it all impact on the oceans and its tides on the earth's rotation that move tides gradually. So next I will talk about how tidal power works. So there are 3 points. So first is kinetic and potential energy. Tides have kinetic energy, that is water movement, and potential energy, high difference between high and low tides. Second is conversion to electricity. Turbines spin as water moves, driving generators to produce electricity. Third is basic working principle. The rising, falling tides push water through barrages or underwater turbines, converting tidal energy into electrical power. So these are the 3 points that how actually a tidal power works. So that was first about water movement. Second was about conversion to electricity. That must be about from windmills or anything. Basic working. Third was basic working principle, that is rising and falling of the ocean and the tides how work. That was the main point. Third is types of tidal energy system. Types of tidal energy systems. There is also 3 points, so let's discuss each and every topic. Tidal barrage. A dam across an estuary traps water at high tide and releases it through turbines at low tide to generate electricity. It is basic and it is very easy to understand that how the tidal barrage work for the tidal energy systems. Then if we talk about second, tidal stream generators. Underwater turbines placed in fast moving tidal currents spin to produce energy like underwater wind turbines. Dynamic tidal power DTP. This is third point. A theoretical large scale coastal structure that captures energy from interacting tidal flows along coastline. These 3 points was the very easy points that we can understand types of tidal energy systems. If we talk in deeply, if we talk about tidal barrage system in deeply and explainly, so it will be like how they work. A dam barrage traps water. Like if I talk about how they work, like tidal power system, tidal barrage system, how it works. There is a dam barrage traps water at high tide and releases it through turbines at low tide to generate electricity. It is the main and the mainly power generator, that is called dam. It traps the water at high tide and releases when the low tides to generate electricity. Example, there are some example like La Rance in France, one of the first tidal power plants. Second is Shiva Lake, South Korea, largest tidal barrage in the world. If we talk about advantages and challenges, advantages are reliable, renewable, and long-lasting energy source. Challenges are like high construction cost and environmental impact on marine ecosystem. That's the main challenges. If we talk about like tidal stream generators, this is the second point when we were talking about tidal generator system, tidal energy system. So this is the second point. How if I talk about how they actually function, underwater turbine spins with tidal currents, generating electricity like wind turbines in the ocean. If we talk about examples, Megan, Scotland, one of the world's largest tidal stream projects. If I talk about its pros and cons, the pros will be predictable energy, low visual impact, eco-friendly, and cons will be high cost, complex maintenance, and the possible impact on marine life. These are the main pros and cons about tidal stream generators. This was the second of that. And if we talk about last topic, it is dynamic tidal power (DTP). So it is large-scale coastal structures, massive tidal barriers built along coastlines to capture tidal energy. Still theoretical, dynamic tidal power (DTP) is a concept not yet built. It is just a imagination and a concept that is in scientist mind and the construction mind that is not yet built. And it is high energy potential, could generate large amount of electricity if developed successfully. In the future we can see it very nearly. So these were the 3 points. If we talk about advantages of tidal power, it is like tidal power is driven by gravitational force and will never run out. This is a good point. And if we talk about second point, unlike wind and solar, tides are consistent and easy to forecast. Tidal power plants have a long operational life, reducing long-term costs. This was also a very good and 100% accurate point. If we talk about fourth point, compared to fossil fuels, tidal energy produces no carbon emissions. Yeah, it's the obvious that they don't produce carbon emission. So these were the advantages of the tidal power. If we talk about some challenges and limitations, there are many challenges and limitations, but we will talk about some limited and common challenges and limitation of tidal power. First is high initial costs, like it expensive infrastructure, dams, turbines, underwater cables, high maintenance cost due to harsh marine environments. This was the high initial cost. This is the main challenge and limitation. And second is environmental impact. This is also main and common, that is challenge. This environmental impact disturbs marine ecosystems and fish migration, can alter tidal flow and sediment movement. And the third is limited suitable locations, requires specific coastal areas with strong tides, not feasible for all countries. It is really not feasible for all countries. Intermittent energy production, and the energy generation depends on tidal cycles, not continuous like solar or wind power. We can compare solar and wind power to the tidal power, but we can't continue it. We can't take as the work of the tidal power as solar and wind power. The fifth is infrastructure and grid integration challenges, require long distance underwater power transmission, difficult to integrate with existing power grids. These were the 5 main and common challenges and limitations that were faced for the tidal power working and also all its feeding. So our next topic is leading tidal power projects worldwide. So there are many, but we will talk about some common or likely which are some famous tidal power projects worldwide. So first is Siva Lake Tidal Power Station, South Korea. It is located in South Korea, the largest tidal power plant in the world, which is 254 megawatt, located in Siva Lake, South Korea. It uses an existing seawall to generate power. And this was first one, Siva Lake, and the second one is La Rance Tidal Power Station, France. First ever tidal power plant opened in 1966. Its capacity is 240 megawatt, lesser than the Siva Lake. It is located in Brittany, France, on the Arance River. And the third and the last one is Annapolis Royal Generating Station, Canada, located in Nova Scotia, Canada. Capacity is 20 megawatt. Operated from 1984 to 2019. One of North America's only tidal power plants. If we talk about some future of tidal power, so it is advancement in technology, more efficient turbine designs for higher energy output, development of floating and dynamic tidal devices, use of AI, and a lot of real-time monitoring optimization. This was the advancement in technology. Second is cost reduction and scalability. Mass production of tidal turbines reducing cost, improve material for longer lifespan and lower maintenance, government incentive and private sector investments driving expansion. Third one is expansion of tidal project. New tidal energy farm plant in UK, Canada, South Korea and China focus on tidal stream energy rather than large tidal barrages. And fourth one is grid integration and hybrid energy systems, combining tidal power and with solar and wind energy for stable power stability supply, improved battery storage to store excess tidal energy. And the fifth one is environmental and sustainability improvement, that is designs that reduce impact on marine life, fish friendly turbines, use of biodegradable materials to prevent pollution. It is good for marine life. The last one and sixth one is global potential and policy support. It is increased government funding and policies promoting tidal energy potential to power coastal cities and remote islands worldwide. So this was okay. This was the future of tidal power, which we can see in upcoming years. So if we talk about comparison with other resources, the tidal power is highly predictable, consistent but limited, minimal but affects marine life, high marine corrosion, coastal areas 50s plus year, challenging due to location, but the other like features, its reliability, energy output, environmental impact, initial cost, maintenance, best location, lifespan. If I talked about lifespan, it was 50 plus years. If I talked about initial cost, it was high. Energy output, it was consistent but limited. Environmental impact, minimal but affect marine life. If we talk about maintenance, high marine coast corrosion. But the solar power, wind power, hydropower, they are not in like, they are weather dependent, seasonal variations. But the tidal power is highly predictable in reliability. So they are in no comparison for tidal power. They are below the tidal power because tidal power is upper than solar power, wind power and hydropower. But it is a type of hydropower. So there was it was comparison with solar power, wind power and hydropower. So there are some reference links that are provided in the PPT file presentation. So for today, and thank you professor, and thank you all of you for listening my speech. And we have submitted our PPT file and the report on the blackboard. So thank you all of you.